Before tapping a keg and serving a glass of beer anywhere, a brewer must tap into a knowledge of chemistry and biology to craft his brew. And it's all mixed with a pinch of the secret ingredient called experience.
You all set?
Yeah,
all right. Can you weigh out 129 grams of calcium chloride? I'm gonna push it to you. We've already acidified this tank with phosphoric acid to make sure that the pH level is where we need it to be. Today, Raleigh City water varies a lot just because they treat it differently sometimes. And it was usually at about 7.5. Today it was at 7. And I'm gonna need to put about 20 more milliliters in there. So we're shooting for 6.
It's 8 a.m. at Raleigh Brewing Company.
You know, the thing about having glasses is that you can't see anything when the heat hits it. All right, that's 100.
There's almost 500 gallons of a beer named Hidden Pipe Porter to be made.
And off we go.
The brewers must precisely choreograph a delicate dance of water, barley, hops, and yeast to make it all happen.
Always love that smell in the morning.
Yeah, the reason I say we're all a bunch of geeks and nerds is because we have to know so much chemistry and science to do our jobs. A lot of brewers like to joke around and say that we're a glorified janitor. We wrangle yeast, we drag hoses, we pour grain, but we actually do a lot of the chemistry behind it ourselves because, I mean, there's no other way to do it right.
First step, grain, in the form of malted barley, specialty grains, and roasted grains, is added to hot water. The pH balance of that water has been tested and adjusted to neutral. That allows for the best brewing conditions. The mix is continuously stirred. The enzymes on the husk of the grain break down starches into fermentable sugars.
We want to make sure that the amount of grain we're adding into the mash tun matches the amount of water that we add in there, so it's not too thick or not too thin. You can have different activity from enzymes if you do it too thin or too thick.
Everything from color to the carbonation levels, the taste, the amount of hops. And the thing is, everything varies every time. We get in a batch of grain and it can have more possible sugars in it than the next batch of grain. And so we have to account for all of that. We have to look at that. We have to account for that every time.
So what's going on right now is, see all the grain in there? And then all the water, which is now, it's becoming wort. It's still water because there's no sugar in there yet because we've only been mashing for 12 minutes. It generally takes between 30 minutes to an hour to have the starches be broken down into sugars that are fermentable later in these fermentation vessels.
When the mix of grains and water reaches the proper temperature, the liquid, called the wort, is drained from the wet grains, which are now called the mash. The liquid is transferred to a new tank, mixed with hops for bitterness, and boiled. Hops are actually the flower of the hop plant.
Now, this is our hot liquor tank over there. I want this water hotter because when we sparge with it, we want it to be about 170 or 172 degrees Fahrenheit.
Brewers say adding hops while the tank is filling makes the beer have a more complex taste.
The theory is that there is a different bonding that happens with the oils to the proteins that are in the wort, and the oils stay with the beer throughout the entire boil.
Until now, brewing has been all about chemistry.
Do it again.
Now the process turns to biology. The mixture is pumped into a tank called the fermenter, where it is mixed with the single-celled organism yeast. Yeast is a fungus, a living creature that essentially lives off the ingredients in the beer. The yeast eats the sugar, leaving behind ethanol, which gives beer its kick, and carbon dioxide, which gives beer its fizziness. That bubbling bucket is the carbon dioxide being released from the tank as the yeast is working.
What's the temp right now?
However, the challenge for brewers is that yeast doesn't always metabolize sugars the same way from batch to batch.
And then we're also dealing with a living organism with the yeast. And it can be a little finicky sometimes. And it's very sensitive as far as temperature. And, we try to get it down to the point where we get consistent from batch to batch because that's what our customer expects.
I want the customer to be able to go to a bar in Wake Forest and a bar in Fuquay and a bar in Raleigh and get the same beer and have it taste the same every time. It's very, very important that that happens. Breweries that don't have that happen don't last.
There's a lot going on in that seemingly milky liquid.
There are about 4 billion yeast cells inside that flask, and microbiologists at NC State are working with North Carolina brewers to unlock and manage the biological secrets of yeast so beer can be brewed more consistently.
Yeast cells are like us. They're a really distinct and diverse population all within here. They're a little own micro world. So within that population, just like us, there's a lot of variability. The variability within their metabolism. So some guys are fermenting faster, some are fermenting slower. My research is to kind of bring them all together. So to really shift and synchronize their metabolism.
The yeast is really what turns the sugars into the beer with all the different flavors and the qualities that the consumer is after. So I think it's key to be able to control your yeast and make sure that they're healthy and that they're the right strain of yeast to do that for your beer.
Wedges underneath it. And
The beer sits for 5 to 7 days while the yeast metabolizes the sugars. Then the yeast is pulled out. The beer is kegged.
So we generally shoot for 1 million yeast cells per milliliter.
Brewers check the yeast to make sure it is alive and viable and can be reused. That's because, in a sense, the yeast are the real chemists in the process. If by now you're amazed an entire industry is centered around the biology of a cell,
It's all based on chemistry. It is. It all goes back to the science.